Hi students, this is T. Balakrishna, Chemistry Lecture, GPT Kottagudem. Today our topic is structure of natural rubber and vulcanization of rubber. Structure of natural rubber. Structure of natural rubber. So natural rubber uh, name is chemical name is polyisoprene. Polyisoprene is contain. Polyisoprene is contain Polyisoprene contain many number of isoprene units. Isoprene also called as 2-methyl 1,3 butadiene. So 2-methyl 1, butadiene structure is 1, 2, 3, 4. Write the numbers. This is 1. This is 2. This is 3. This is 4. 1, 2, 3, 4. It contains 4 carbons. So there is buta. It contains 2 double bonds. That is called diene. But double bonds are at the first position and third position. That is called 1, 3 butadiene. And it's also have one substitution. That is 2-methyl substitution. The methyl group is substituted at the second place. That is called 2-methyl 1, 3 butadiene. Here 2-methyl 1, 3 butadienes are participating polymerization. They are naturally formed, but the reaction between the monomers, these monomers are combined to form polyisoprene. What is the reaction between this one? Okay, this is isoprene. When the reaction takes place between these monomers, the double bond is missed between the, so this double bond is, all the double bonds are converted into single bonds. All the double bonds are converted to single bonds. Okay, right? Before saw the diagram, it have 1, 2, 3, 4, 4 double bonds. These 4 double bonds are connected into single bonds. 4 double bonds are connected to single bonds. Single bond, single bond, single bond, single bond. Okay, right? Next, uh, single bonds are connected to double bonds. So its single bond is connected to double bond. This single bond is connected to double bond. Okay, this is a double bond. Next, they form new bond between the two, a new bond formed between these two atoms, these two molecules. Okay, this is new bond. Okay, this is a structure of natural rubber. Okay, so before bond formation, it has 2 double bonds. So these 2 double bonds are connected to double bond is, so you observe these two molecules before bond formation. It has double bond between these two carbon, but it is connected to single bond. This single bond is connected to double bond. Okay, this double bond is connected to single bond. So that means you easily remember double bond is connected to single bond is connected to double bond is connected to single bond. That is the difference between isoprene and polymer. By using of this technique, we easily write the structure of polyisoprene structure, that means natural rubber structure, and also write the isoprene structure. Okay, right? This is the structure of natural rubber. Is it clear? Right, student? I come to the topic. Is the structure of natural rubber. Next, we are going to discuss about the vulcanization of rubber. In this vulcanization of rubber, the process of heating the raw rubber with sulfur at 110 degrees Celsius to 140 degrees Celsius is called vulcanization. In this vulcanization process, in this vulcanization process, in this vulcanization process, the sulfur combines chemically at a double bonds of different rubber springs. So this process the stiffness of the material and prevent the intermolecular movement of the rubber springs. The characteristics of vulcanized rubber is depending upon the movement of the amount of sulfur used in the vulcanization, the temperature at which vulcanization is carried out and duration of vulcanization. So before going to discuss about the vulcanization, so you saw uh, this diagram. This is this is a rubber. So it is a one spring and another spring. When you apply the stretching force, these molecules are moved towards the right direction. These molecules are moved towards the left direction. So the rubber sizes increases. That is called elasticity. When you apply the external force, some rubber springs are moved towards one direction. Some rubber springs are moved towards one direction. So it automatically looks it expanded. That is called elasticity. So rubber shows the elasticity due to the intermolecular movement of the rubber springs. So raw rubber have high elasticity. Raw rubber have high elasticity. This is not useful for our daily activities. So if you want to use this raw rubber in daily activities, you should vulcanize it. When you are vulcanized the raw rubber is converted into economically and useful and industrial rubber. So in this process, this raw rubber have high elasticity, so it is converted into useful rubber. You should use vulcanization. In this vulcanization process, we should add sulfur at 110 degrees Celsius to 140 degrees Celsius. 110 degrees Celsius to 140 degrees Celsius. So this sulfur, which atom we are added to the process, the sulfur is added between the two rubber springs. Added to the two rubber springs. Where it is added in this vulcanization process, the sulfur combined chemically at the double bonds of different rubber springs. Double bond where the double bonds are present. So here the sulfur is added between the two rubber springs where it has a double bond. Okay. So I try to explain. Okay. So here the sulfur is added between the where the double bonds are present in the rubber spring. It is a one rubber spring. It is in a one rubber spring. When you add the sulfur, so here the double bonds are here the double bonds are here double bonds are missed, and here one sulfur is added between the rubber spring. One sulfur is added between the two rubber springs. It is a sulfur. Okay, right. Next, another sulfur. Okay, is it clear? So here you remember the sulfur combined chemically at the double bonds. The sulfur is combines chemically at the double bonds of different rubber springs. So where the double bonds are presented, at that position double sulfurs are added. This is a very important point. Okay. Before vulcanization, this is called raw rubber. Before adding of sulfur, this is called raw rubber. When it is uh, add some amount of sulfur at 110 degrees Celsius to 140 degrees Celsius, it is converted into vulcanized rubber. So when we add this sulfur, it prevents the intermolecular movement. So automatically the elasticity of the raw rubber is decreases because raw rubber have more elasticity. If you want to convert it as useful rubber, you should vulcanize it. So this vulcanized the vulcanized rubber character is depending upon amount of sulfur used in the vulcanization and the temperature of vulcanization and duration of vulcanization. Okay, right? Thank you, students. This is T. Balakrishna, Chemistry Lecture, GPT, Kottagudem. Thank you. Thank you very much.